Hello everyone, I'm Rajeshri, Assistant Professor of Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And in today's lecture, we will be discussing three-phase half-wave converter with RL load. Here if you see, in three-phase half-wave converter, R phase will be connected to thyristor 1, Y phase will be connected to thyristor 2, and B phase will be connected to thyristor 3. Here we are making use of three thyristors which are connected to load and to RL load, and then the other terminal is connected to neutral and back. See, during the positive half cycle, that is the moment when R phase is being appeared. See, this is the zero crossing, and at this instant we call it as pi by 6. This instant is pi by 6. This is the zero crossing, beyond which only we can trigger the respective thyristor, and before which it will not be triggered. And see, here R phase is being appeared at this right from this instant called pi by 6, and beyond this pi by 6, if we can provide the triggering pulse, in that case, since R phase is connected to thyristor 1, this thyristor 1 will be coming into the conduction state. So, at this instant called pi by 6 plus alpha, here we are providing the triggering pulse pi by 6 plus alpha, where alpha is equal to say 60 degrees. Here thyristor 1 has come into the conduction state, and it is conducting right from this instant till pi. That is, this is the instant where R phase is remained positive, beyond which it is turning out to be negative. So, here thyristor 1 is conducted till this instant. That is, when thyristor 1 is conducting, this is the individual circuit diagram. See here, thyristor 1 is conducting current through the load, RL load, through neutral and back to supply. That is, now, when the current is flowing through the load, when thyristor 1 is short circuited, and when current is conducting through the load, at that instant, initially the polarities across the inductor when it is charging is positive, negative, and by the time when the energy stored in the inductor is complete, the polarities will be, its polarities will be negative, positive. It is because of the Lenz law, it reverses its polarity, because as soon as negative half cycle is appeared, actually thyristor 1 need to get turned off. But here, because inductor does not allow any sudden changes in the current, in order to maintain the current through the load, it reverses its polarity to negative and positive, and because of these polarities across the inductor, thyristor 1 is still maintained in conduction even during the negative half cycle of the supply voltage. So that is the reason, whatever the energy stored in the inductor. What is the energy stored in the inductor? The voltage across the inductor here is VL is equal to L into di naught by dt. So whatever the energy stored in the inductor will be dissipated through the load through this particular, by maintaining this thyristor 1 still in conduction state even during the negative half cycle. So that is how we are getting the output voltage right from pi to pi plus alpha. And the moment it reaches, whatever the energy stored in the inductor is completely dissipated, and now by this time the inductor is completely exhausted, and that is the reason at this instant, since Y is already appeared, and if we can provide the triggering pulse at this instant, the thyristor 2 starts conduction because it is connected to Y phase. Thyristor 2 comes into the conduction state, and thyristor 2 is conducting, and the moment it reaches here, Y phase is turning negative, at this instant actually T2 need to be turned off. And as I told you previously, because of the energy stored across the inductor and the polarities across the inductor will be reversed, that is negative, positive, and and during this instant, T2 is still maintained in conduction even after the reversal of the supply voltage. T2 is still maintained in conduction, and that is how T2 is conducting a current through the load. Whatever the energy stored in the inductor is dissipated through the load through this particular thyristor 2. And that is how we are getting the negative spike. And this negative spike is present as long as the energy stored in the inductor is completely dissipated, and by the time the energy stored in the inductor is completely dissipated and the moment it becomes zero, at this instant here B phase, that is R, Y and B phase comes into the picture now. And now since B phase is forward biased, now thyristor 3 comes into the conduction state. Thyristor 3 comes into the conduction state, and that is how thyristor 3 is conducting current through the load. Thyristor 3 is conducting current through the load, and as I told you, by the time it reaches this instant, negative spike is appeared because of the energy stored in the inductor. And now talking about the output current. Output current, since we are making use of a very large value of the inductor, the current flow through the load is continuous and it is almost considered as a straight line, and that is how we are getting the output current as a straight line. This is the output current waveform. And here talking about the current through the R phase. That means current through the thyristor 1. See, current through the R phase, thyristor 1 is conducting right from this instant called pi by 6 plus alpha, where we have considered alpha is equal to 60 degrees. So that is the reason here thyristor 1 is conducting right from this instant called pi by 6 plus alpha to pi. But here thyristor 1 is even conducting beyond pi, that is from pi to 5 pi by 6 plus alpha. So it is conducting for a period of about 120 degrees. So as long as thyristor 1 is conducting, current will be flowing through the thyristor 1. So this is the current through the R phase or current through the thyristor 1. And again, and if you see, always current through the thyristor 1 is positive, even during the negative half cycle. And it is remained 0 because thyristor 1 is not conducting. And again at this instant called R phase, after 0 crossing, where alpha is equal to 60 degrees, thyristor 1 comes into the conduction state, and that is how thyristor 1 is conducting. How long? That is for a period of 120 degrees. That is 180 by 3 thyristors. And here thyristor 1 is again conducting, and with a magnitude of I naught average, output current magnitude I naught average. Here this is the current through the R phase during the period when thyristor 1 is actually conducting. And again this is the current through the Y phase. That means since Y phase is connected to thyristor 2, this is the current flow through the thyristor 2 while it is actually conducting. So here at this instant Y phase, when we provide the triggering pulse, thyristor 2 is coming into the conduction state and it is conducting as long as thyristor 2 is on. Again, during this period, thyristor 2 is on. And this is similarly, there is a current through the B phase. So current through the B phase is the moment 0 crossing, and this is alpha, and from this instant called alpha, here your thyristor 3 need to conduct. And how long? For about a period of 120 degrees. That is, even during the negative spike, thyristor 3 is conducting, and till this instant there will be a current flow through the thyristor 3, or this is the current through the B phase. And now here again we have indicated the current through the thyristor 1. See, as long as R phase is present, that is thyristor 1 is conducting, we get the output voltage or current through the thyristor 1, that is right from the instant called pi by 6 plus alpha 2, and it is conducting up till 5 pi by 6 plus alpha. This is the current through the thyristor 1. Hope you understood. Because there is no freewheeling diode, we are getting the negative spike in the output voltage waveform. And let us obtain the expression for V0 average. Here, if you see, V0 average expression is one and the same for the R load and RL load. And here, V0 average is equal to time period 1 by T 0 to T V0 of omega T d omega T, where here time period is, it is conducting for a period of 120 degrees, so 2 pi by 3, and it is actually conducting from alpha to, that is pi by 6 plus alpha. Zero crossing is pi by 6 plus alpha we have taken as 60 degrees, and it is conducting till a period of 5 pi by 6 plus alpha, is it not? See, it is conducting from pi by 6 plus alpha to 5 pi by 6 plus alpha for a period of 120 degrees. So here 5 pi by 6 plus alpha, and this is V0 is, we have Vm sin omega t d omega t. So taking this 3 up and bringing this constant Vm out, 3 Vm by 2 pi, conducting from pi by 6 plus alpha to 5 pi by 6 plus alpha, and integration of sin omega t is minus cos omega t. We get, if you resolve this expression, we get V0 average is equal to 3 root 3 Vm by 2 pi cos alpha. This is the V0 average expression for 3-phase half-wave converter. Thank you.